Hello, everyone. You're welcome to another exciting moment with me. And we are going to be looking at plane shifts. We have been looking at plane shifts. I think this is the third questions I'm going to be solving, but this one is a little different because we are considering an equilateral triangle, and we are going to be placing these charges in what are the corners of this equilateral triangle. So we want to see how problem can or how we can find our net force on one of the charts that will be placed at the corners of the word or one of the apex of the triangle of an equilateral triangle. As you listen, God bless you. Now, the question says what three charges Q1 equal to 3.7 microcoulombs, Q2 Q2 equal to minus 3.7 microcoulombs, and Q3 equal to what 4.8 microcoulomb are fixed at the corners of the equilateral triangle. Of side 3.0 times 10 to the power minus 2 meter full stop. It says find the magnitude and the what direction of the net force on the charge Q3 due to what other charges. Now, we want to solve this problem. First of all, I will advise us to work to draw our equilateral triangle because the questions have to do with what equilateral triangle. We know that our basic mathematics, when you draw an equilateral triangle, means all sides are equal. All sides, this place is equal to this and equal to this. Now, if all sides are equal, and they said what three charges Q1, Q2, and Q3 are placed at the corners of what? Of the equilateral triangle. So let's place our what? Q3 here is what? Minus what? Let's say this is what? Plus 4.8 microcoulomb. Okay. Then we have one again at, let's say our Q1 is what? Plus 3.7 microcoulomb is here. Then let's have this what as minus 3.7 microcoulomb. Now these are the what? And each of these triangles, the side of the triangle is what? What is it? 3 times 10 to the power minus 2 meter. Here is also 3 times 10 to the power minus 2 meter. 3 times 10 to the power minus 2 meter. That's what they give, because all sides are equal. If you don't understand that, then you cannot know how to place your side, the side direction or length given to us. Now, what do? We want to find the what? This is Q3, don't forget. This is Q what? 2. While here is Q1. So we want to look for the net force on Q3. The net force on Q3. Don't forget this one is going to be 60 degree. If you don't know it now, but here will be 60 degree, and this other place will be what? 60 degree, because it's an equilateral triangle which sum up to 180 degree. 60 plus 60 is 120 plus 16 is 180, which is angle. Sum of angle in the triangle must be equal to 180. That is clear. Now, to calculate the net force of what? The influence of minus 3 microcoulombs, minus 3.7 microcoulombs on plus 4.8 microcoulombs, is going to give what they call an attraction. So it will go like this. It will attract. So the influence of minus 3 will be what? Attraction here. Then what about the influence of plus 3 microcoulombs, 3.7 microcoulombs on plus 4.8 microcoulombs? Look at what will happen. Let me put it here. It will cause a what? A repulsion this way. That is repulsion along the line, not away from the line. Along the line. So look at it here. So this one is what? F1 on 3. This what? F2 on what? On 3. So that is it. Now, if you now have this is now a shape that has been formed at Q3. This Q3. Now, what do we do, class? I will advise us to what? To draw the angle out. This is what? This goes like this. This is what? F1 on 3. Look at this. Q1 on 3 charge. This plus 4.8 microcoulombs. Then we have another one like this, which is what? This F2 on 3. That means Q3, Q2 on 3, on charge Q3. Don't forget this is the Q3 that we're talking about. Now, the angle between what? This and this will be 120. Remember, this is a straight line. So if it's a straight line, if here is 60, here will be what? 120. So here is 120 degree. Okay? If that is 120 degree, let's find what? The force, one after the other. I want to change my marker. Let's find the force. F23 will give us what? Q2, Q3, all divided by what? R what? 23 squared. Let's find the force first. So when you look for the force, what happened? 9 times 10 to the power 9. Absolute of Q2 is what? Minus 3.7 times 10 to the power minus 6. Micro is minus 6. Then Q3 is 4.8 plus times 10 to the power minus 6. Divided by what is the distance apart between Q2 and Q3? Is about the same what? Okay, 3 times 10 to the power minus 2 all square. You get that one for me? Okay, now let's find the one. This the what? F what? 1 and 3. Q1 on Q3. So that is what? F13, which is charge Q1 on what influence on Q3. What do you have? K, Q1, Q3, all divided by what? R13 square. So I would have 9 times 10 to the power what? 9. Yes, what do we have next? Q1 is what? Plus 3.7 microcoulomb, which is times 10 to the power minus 6. Okay, 3.7. Then the second one is what? Q3 is what? See 4.8. So I would have what? 4.8 times 10 to the power minus 6 divided by what? What is our radius? Check my mic. Okay, it's working. So our distance between what? Q1 and Q3 will now be what? Still the same distance. 3 times 10 to the power what? Minus 2 all square. Already in meter. So we don't need to bother. I don't think we are going to have different answer. Looking at they will have the same answer. So when we solve for one, we can assume the other one 2, 3. They have the same answer there. So no need to bother ourselves. Let's press our calculator. Let's press our calculator and let's see what we have. You can do that alongside with me. Then times what? And times 4.8 says power minus 6. Then all divided by what? I would have all divided by what? 3 times 10 to the power minus 2 all square. All square. So what do we have? We would have it as what? 177.6. 177.6 Newton. So that's what I would have. 177.6 Newton. Now, in this case, now, I will advise us to use vector analysis to resolve this. I think it will be very easy for us, and it will what? It will clearly what help us to be able to what? Calculate our direction without stress. Now, you take one of the force. Which one come first? I think Q1 come first in the question on 3. Q1 on 3 is what? Q1 on 3 is F13. So F13 will take what? 0 degree. You are going to what? Look at the board, what I'm saying. Let one of the force be the starting point, which is 0. Then the second will not take the angle. The second will take this angle between them. So which charge comes first? Q1 on Q3. Q1 we have first influence on what? Q3, which is taken as 0. That means as the direction of 0. Then Q what? 2 on Q3 will not be what? 120 degree direction. You understand me? So that means that we are going to give Q2 on that means Q2 on 3 as 120 degree direction, which is the angle between them. Then Q1 will take the starting point. Q1 on Q3 will take the starting point, which is 0. So that when you now want to resolve into X and Y component, you now be what? F13 cos theta, F13 sin theta. Go and watch my vector analysis. I did vector. I'm using vector analysis now. So this one have what? F23 cos 120, because all these angles are starting from the horizontal, from the positive X direction. So your X will take cos while your Y will take sine. So in that case, this one will not be what? F23 sine 120 degree. So that's what I'm going to use now. So what I want to do now is, and I want to say the summation of the force along the X is what? Is now equal to what? F13 is what? What is 13? Same thing. 177.6 cos what? This is 0, sorry. It's 0 degree. 0 degree. So cos what? 0 plus what? Plus 177.6 cos 120 degree. So give me the answer to that. Then what about was sigma what? Fy, total forces along the y-axis. Let me change my marker. Okay, so we want to have what? 177.6 along the y-axis sine 0 plus what? 177.6 sine 120 degree. So this 120. So what do we have concerning this? Now, if you can get our answer, we can go down to finalize our solution. 176.6 cos what? 0 plus 177.6 what? Cos 120 degree. So that will give us what? 88.8 Newton. Then what about this other one? 177.6 sine 0 plus what? 177.6 sine 120. Okay, this one will give us what? 153 point what? 806 Newton. So that is what I want to have for X and Y. Now, to find the final resultant, to find the net force, we now what? We have resolved it. We have turned it to two-dimensional. And the two-dimension we have turned it to what? In the first quadrant. Look at it. One is what? A 153.806, which is on the y direction. The other one is what? 88.8 Newton. So now, this is the net force we are looking for. And this will be the direction we are looking for. So it's very easy now to solve our problems. So this is what? Now, we're now going to use Pythagoras theorem to find the net force. So net force will now be equal to what? Square root of what? 88.8. The square along what? You know what you are using now? You are using what? Net force is equal to what? Net force is equal to square root of what? Sigma fx square plus sigma fy square. This is what I'm using. So take note of that. That's what formula I'm using now. So this one is square plus what? Then 153 88.806 all square. So this is 88.8 all square. So what do we have now? Let's press our calculator and let's see what we want to have. 88 point what? 153.806 square plus what? 88.8 square. So square root of everything will give us what? 177.6.59. 177.59, which is approximately what? 177.6 Newton. That is our magnitude. But how do you find your direction? What you are going to do is that you find direction, you see use our formula, which is tan theta equal to what? Fy over Fs. That's what I want to use. So if you want to do that, mean theta will now be tan inverse of what? Fy is what? 153.806 divided by what? 88.8. So what will be your answer if you do that to find direction? Now that is the formula for finding direction, which we have talked about. I think I've been using that formula, so you should be familiar with it. Now 153.806 divided by what? 88.8. Then an inverse, that should be 59.9. 59.9. That means the direction now. The direction here is for 59.9, which is theta is equal to what? 59.9 degree, which it can be taken as 60 degree. Can take it as 60. 60 degree. Can be taken as 60 degree. So either you leave it as 59.9 or you leave it as what? As 60 degree. So now somebody else can say, Mr. Ali, I want to interpret it not east, 60 degree what? North. This one is east, this is north. You can say east, 60 degree what? North. So you are still correct. So all those things are very, very important. You can even say 30 degree here. Here is 30. Not 30 degree east. It's still correct. But the direction is 60. While the magnitude is what? 177.6 Newton. Approximately, let's say 178. It depends on the exam and the options or whatever you want to solve. The decimal point you want to solve it to convert it to. Thank you very much for watching my video. See you in my next video. Thank you.